Good afternoon, everyone. So I'm Norbert Paquet, I'm the head of product management for Sony Europe, and I look as well after IP solutions. And it's difficult to be the last one speaking today because there's a lot that has been covered. So I'll try to go around system architecture. I'll go back a bit on the NEP case because I'd like to focus for a second on the business benefits of it. And the last challenge, which Phil has mentioned, which is about the control layers overall. So we're talking about standards and ST21110. One thing which is very important is that ST21110 is not everything, and especially when it comes to build a system. You've understood that ST21110 enables to transmit all the different essences, audio, video, metadata, and throw them into a network. But as Gerard said, networks has basically forwarding packets and so on. So you need a level of intelligence, which is why AMWA is working on the NMOS series of standards. So just to recap, because it's been covered already fairly in large scale today, but that's the current status of the 2110 family. We summarize ST21110 as one standard, but actually it's a family. So you have to be very careful when you read datasheets, when you talk with your own vendors, that we all speak the same series of standards and the same implementation, because that's where you're going to look at having an interoperable series of systems. Just because it has been touched upon, there are a couple of work in progress. The beauty, again, is that the fundamentals are there, -20, -30, -40. But there is some work still going on the compressed video transfer, Phil touched upon it. And the -23 as well for the multiple stream transfers, which is going to be useful for some legacy equipments, like, for example, the EVSEs, which are used to work with video phases for the iframe rate, for example, or for bringing a compatibility into quad streams. Because the -20 is very important, is single stream. Okay, so it's like a 12G SDI, it's a single stream, whether it's 4K, HD, high frame rate, it's a single stream under the same session description protocol, and uncompressed, of course. Some further work as well on general metadata transfer and SDP, and as well, and I put it as part of the 2110 family, it's been touched upon, but the 2110-10 mandates the use of 2059-2, which is the PTP. On the NMOS family, there is also some work in progress. IS04, 05 really are there and really important. I'll touch upon it in a second. IS06, we talked about. I agree with Phil that there is already other ways of implementing the network control and so on in other manners, but the version 1.0 is there. And then other things, event and TOLI and audio mapping are on the way, and some discussions are ongoing within the NMOS family. I like this slide because at some point you might be puzzled as well with all these standards and how do I build a system with all of these, and how do I make a specification, how do I ensure vendor A, vendor B, vendor C talk the same language. I often take the key as an example. When you try to open your door at home, you see all these pins on your key really fitting the locker and opening the door. Break one pin, you won't open the door. But that's the same when you build a system. You need to ensure that all the vendors, all the different parts of the systems talk the same language and align together. And EBU released in December a very, very nice document called the Tech 3371. It's a recommendation, but it aggregates in a very logical way the 5 key elements that you need to think about from the media transport, because often I receive the question, is your equipment ST21110 compliant for me to build an IP system? No. Actually, you need the media transport with 2110-20, the software-friendly approach with the -21 when you have software-driven like playout systems that are sending large bursts of data flows instead of the narrow senders who are sending very, very rightly timed video packets. The audio part and all the profiles associated, at least having the level C support, and the stream protection. Then you go into time and synchronization, PTP version 2, and its redundancy as well. It has been touched upon earlier this morning. The synchronization of audio, video, and data essence. How do you apply this timing information, which is distributed on the network, back to the essences? Then you go to the intelligent part, which is the discovery and connection. You don't want to go into register all your device manually, and especially if you're an OB provider or if you have dynamic operations, you might have a system which change the number of devices, the function of the devices. You want to have the capability to discover and register everything, and the cross-point switching through the IS05. The audio mapping is a work in progress with the IS08, and then the topology discovery, LLDP, can be very much used already. Configuration and monitoring, I'll touch upon that in the end, but also how you manage the configuration and the management of all the IP addresses in the system. you now have an IP address for the source, a multicast address. You have as many as you have number of streams, and then multiplied by the number of devices. You very quickly end up with thousands and thousands of IP addresses to manage. How do you simplify that part? The open configuration management of the devices, of the network switch, for example, and the monitoring protocols, where you have a lot of data at each devices that has to be brought together into monitoring systems and tools. And last but not least, because when you're talking about IP, often you have someone knocking at your door talking about security. EBU also reminds some security recommendations, which is kind of a big and heavy checklist, but is worthwhile to think, especially if you're planning to merge at some point the wider production infrastructure that you have, leveraging a converged IP infrastructure. So the general architecture overview in a very simple manner is that you're going to have your operational layers, and you want that to be as it is today. You really want to have your operators operating the way they operate today. A vision mixer will operate in the same manner. The broadcast operator, the system engineer, we have to bring them tools to be able to monitor their system with the use of the broadcast controllers. Then you have your IP network with the network switch, the network controller. It's been touched upon by Arista earlier on. And then you have your different devices from acquisition to process and distribution, comms and audio and production all together. But then how you start to interconnect that and try to have then a consistent approach. So in terms of architecture, you might wish to use the existing systems that you have. VSM is one of them. You might use new system which has been designed for IP, and then you will try to control and switch into your network fabric. So I try to go in a simple manner, where the first thing is you have your discovery and registration. That's the role of IS04, where you will bring into a single and common database all the series of devices that you have around your network and their capabilities. Am I a video sender, a video receiver, an audio sender? Do I do both? A CCU, for example, will be able to output 3 videos, have the video returns, the comms, the audio outputs, and so on and so forth. A vision mixer will have a series of inputs, a series of outputs. So that's the description you're going to get on the database. Then you will have everything starting to send streams over the network, but you want your destination, whether it's a multi-viewer, a switcher, and so on, to subscribe to it. So this is where you're going to use the AS05 to be able to command that and ask a subscription into a source. And this is the fairly disruptive thing for traditional broadcast engineers, because in the SDI domain, what you do is that usually you close physically a crosspoint from a source to a destination. In the IP domain, it's the opposite. It's your destination which has to grab and subscribe to a source. And that's the first psychological element, which is very important to understand, because then you can think and design your system with multicast in mind. And if you continue to think through SDI, through closing crosspoints, despite it behaves the same at some point from an operational point of view, you might miss an opportunity as well in architecturing and designing and then integrating your system. And then you get your flow. The TOLI element, it's also important. You want to get TOLI, so IS07 is not there yet, so there are existing open protocols, NSBus, TSL, and so on and so forth, where you want to be able that when you switch across points from the visual mixer, you get the red tally onto the cameras, onto the multi-viewer, onto the VS operator's position, and so on and so forth. But that's also something that from a system integration point of view, you need to aggregate this and think, again, with the right protocols that everybody talks at the same level. And last but not least is configuration. So we have some capabilities on the Sony device to help with the IP address configuration through the Live System Manager, but still most of the individual devices needs to be set up one by one, manually, whether it's their video formats, their characteristics. If you take a switcher, how do you use the ME, you allocate the resource, and so on and so forth. And this is where I'll talk about in the end, about the control systems, because now everything is connected, both from a control and a media perspective into a network. Then we can start to unify and go one step deeper in terms of orchestration and control layers. So with all that in mind, that's very important, as it has been said all around today, that all the vendors work together. Sony took an initiative 5 years ago around the NMI technology, which now we are implementing ST2110, but still the work of interoperability is important at system level. one thing we realized is that when we go together with Lavo, with Aristam, with all these vendors to IBC or NAB or the IP showcase, you will see a 2110-20 corner, you will see an NMOS corner and so on. When we go to a customer and we're discussing a project, we talk about a system. So we're doing a lot of system verification tests, so that's why we work together, and we are capable also of having this type of conference, because when we go to a customer, we need to make the system work together. We talk about NEP, and this calls for me a new term which is very important, which is called remote integration. Often we talk about remote production, but remote production is just a simple contribution of feeds from one side to another to produce remotely. The first benefit comes in mind of saving cost of travel and resource, and when you are in large territories such as Australia, Brazil, US, Canada, and so on, it makes perfectly sense. But if you want to build a business case which is really, really relevant, and that's what NEP Australia done, is to also be more flexible in the way that you interconnect your resource, and then you can pick up, whether on-site or remotely, the different sets of resource that you have. And your resource can be human resource, can be equipment, and also it depends on the production scenarios, because in the case of NEP Australia, you have a director who accepts to produce remotely. Of course, for him, the benefit is right. He said it's 3 days of travel saved by doing the centralized production. But in some countries in Europe, the producers, the director and his production team, they want to be on the stadium, they want to be on site, so still they want to travel. But how we can pick up resource for them and be very flexible to cope what service providers or broadcasters have to do against production requirements. So if I go back to the NEP case study, again, you have this remote operation case where you have the IOBs, and then you take and pick up some resource from the hubs. But then it has been said many, many times, both of the facilities, whether the hubs or the IOBs, can work independently. And that's where the business case of remote integration becomes very, very pragmatic and relevant in investing so heavily into IP technology, is that you cover really, really 3 cases. The remote operation, I have a big event, I need to pull out extra series of resource, and I have the day-to-day business. So usually, well, I know in the UK you have football almost every day, but in France, for example, we have not that much football from Monday to Friday or second league games, very small ones. So you have really a medium operation. I need a mid-sized truck. But then over the weekend for the big League One games, I need the big truck. But maybe tomorrow I can keep my medium truck for the League One games and just pull out from the central hub more resource to just cover the Saturday, Sunday games. So that's really a business case which is important to keep in mind, because if we talk about IP through just a technology window, it's going to please a lot of engineers, and I'll show 2 pictures later on that's going to please more than engineers, but the business case doesn't stack up, because from an investment point of view, it's not cheap. The investment at the point of building the system can be heavier and more expensive than building an SDI system. But the return on investment gets over time, gets over the resource that you save and the flexibility that you get. So that's the picture that usually brings engineers very happy, because you see that the CCU is not anymore a big breakout box with lots of cables and complicated interface, but you have only the 2 fibers, the red and the blue network, you have the control network, but that's it. And you have everything, which is also a challenge, again, this shift of mindset, the abstraction between the physical layer and the logical layers. Because out of these blue fibers here, you have everything. Video outputs, returns, comms, audio, everything. So also, then the challenge is that when you have this abstraction, where today you have a picture glitch, you go into the patch panel and you follow the cable, you follow the signal. How do you do that in IP? So this is where we're going to need to bring some more tools. The first thing we discussed this morning, I heard about virtualization, about cloud production. And often I'm said, oh, when your Sony switcher is going to go in the cloud and so on. So yeah, we can do it for streaming type of services with low bandwidth, high latencies, and so on and so forth. But when you have a switcher which has to cope with 160 inputs, 40 outputs, basically a lot of real-time processing with only 1 line delay, how do you do that in the cloud? So still we need hardware support behind in terms of processing, but we can start to think how we can make our resource more intelligent. And again, it's all IP connected. From the panels, to the back end of the switches, then we can bring some better ways of utilizing the resource, and again, in the spirit of aggregating and or pulling in and out set of resource from not only an EVS, but certain channels of an EVS, or not a full switcher processor, certain part of the processor, a couple of MEs, a couple of keyers, certain frame memories, DMEs. That's what I need from a production standpoint. Now we do that. As I say, the challenge comes into resource orchestration. Now I have all connected, I've followed all the standards, I've architected everything. I have a lot of products, I have a lot of components, and then I need to aggregate them and control them. So let's start at the IP domain first. We have solutions that can discover, like through IS04, a series of devices and so on, and you can look at them. We can bring some status and so on. We can integrate with existing third-party systems. So that's how, for example, in NEP Australia or at SIC in Portugal, people keep using VSM. So we have changed from SDI to IP. Nothing has changed for the operator. That's beauty. They still have a cross-point matrix. They can switch a source to a destination. Again, the way it behaves behind is different, but the way it operates and the GUI for the user is the same, and we bring that in front of them. But now becomes new challenge. We talk about tools. How do we have a network monitoring? So fortunately, the IP switch have a lot of interface, and we can try to translate what you've seen in very nice series of CLI commands from Arista into graphical views. Because as I said, if you have to diagnose something very quickly, you need the right alarms, the right tools, because you can't anymore follow the cable that much. You have to follow the signal from a logical point of view. So bringing some views of the network. Same for the PTP. How do you diagnose the PTP information? How do you translate the CLI command into something which very quickly, especially in the live production domain, you can diagnose and know what's the status and where the error is coming from. So that's one thing we are trying to provide from a broadcast vendor perspective to our broadcast operators, a series of tools that enable them to leverage, again, the business power of IP on the one hand without disrupting the operations, because that's also a challenge, and I'll talk back about training afterwards. Now you have all connected, you have systems, they can be in different locations and so on and so forth. The main idea is how do I orchestrate everything? Because then if you have to reconfigure from the program A to the program B with very heavy reconfiguration, it's not only the routing, it's all the device formats. You have a show which is running in 1080i, and then the next show is in 25 PSF. So there are lots of configuration, your format system change of the switcher, the studio cameras, your multi-view, and so on and so forth. So this is where orchestrators start to play a big play. And again, we need to have a deep access to the different devices, and that's what we call device drivers. So for that, we're going to work in developing orchestration tools, which are going to keep, again, under the same unified user interface, the way you can access the device, configure it once for good, and save it into templates. Because the resource can be many things, and is not anymore related to a physical resource, except its physical location. A switcher processor, as I said, can be one big entity, or can become a smaller set of entities. It's a resource. It's one ME, 8 keyers, a DME, a couple of frame memory channels, and 10 inputs, 5 outputs for a small production. And then the rest is available to go for another production, into another studio, into another location, wherever. Then you have a group of cameras, you have a group of processing, and so on. But the most important thing is, again, how do you bring from a very abstracted, virtualized kind of environment a very pragmatic and practical view for the user. So the user interface are also very important, building a series of monitorings, and also having a relationship with what's the core of the broadcast business, which is creating program. Okay, so what we're going to call a service from an engineering point of view will be a program from the program people point of view. And again, as I said, monitoring the different aspects, translating, again, a lot of techie information, a lot of diagnosis-related elements that you need to have to operate in the stress or the speed of live production, is how do you monitor your network. The Arista switch, a lot of APIs from all the vendors. Sony provide APIs to Lavo for VSM to perform in the same way this type of functions, vice versa. But really the goal is, again, now you're connected everything through IP, you have not only the streams, the intelligence of cross-point switching, but you also have an intelligence of managing the infrastructure. And this is where, again, the business benefits will come, providing a view of all these resources that can be from an operator control panel down to a processing or a production resource, benefits for the large infrastructures. So just a couple of slides again. You can centralize things, and that works with third parties. The last thing I wanted to cover about was asked as a question. I'm very pleased about that. Is that next to here at Pinewood Studios, we started to build already 3 years ago a small IP studio where you see there are different vendors' equipment, because we are identified, and I identified actually at the first for my own team, for my own product specialists. They are very good broadcast engineers and so on, but I realized that when they have to talk IP with our customers, they need to understand that extra layer. And I'm in agreement with what has been said earlier by Phil, is that it's better to teach broadcast engineers about IT technology rather than teaching IP network engineers broadcast technology. It took me 10 years as a network engineer, fundamentally, to work broadcast. I think it's going to be much faster because IP in the end is not so complicated. As long as you have a good glossary of protocols and understanding of multicast, which might be, again, the last thing which is the most difficult to change the mindset, you get it. So we have this training environment. We do 3 days of trainings on ST2110, NMOS, multicast. Almost every time they break down the system and they rebuild it. And sometimes they are short of time, so I always have to send an engineer to finalize. But this is the type of thing, and you see, again, we are not bringing only Sony products, but we work with Lavo, with Tektro, with Mainberg, with Arista, with other vendors as well, to bring a practical system for customers to train their engineers, to even sit down and plan their projects, and we think is important. And even that course from my home country, France, where we have this right for training, so basically our companies, wherever you work in banking or broadcast or everywhere, we pay a fee every month for training companies to deliver trainings. We license that course for the official training institutes in France, and that's they are running a course every month. But that's very important. We have also to educate universities and media schools to teach more about IP into their programs, because in a way or another, both worlds are going to converge anyway. So one thing we have to work on together, again, when we are planning systems, and again, I'm in agreement with Phil, it's not a box business, it's a system and solution business, that we have to learn about the technology, understand, again, this abstraction between the physical and the logical layers to be able to articulate, again, what my system is going to deliver in terms of business benefits. Because if you plan your hobby truck or your studio in the SDI and you just look at removing SDI to cable in IP, I don't think you're going to save a lot of money. Actually, it's going to be more expensive. And the reality on the day-to-day is going to be different. So you really have to anticipate that and think, okay, what's the business goal I have using IP technology? You have to design. Very excellent sessions this morning on network, on PTP, and so on, starting by the foundation of the system. Network is the foundation. It's like a house. If you mess up with the foundation, you're building on a crackdown. I was at a customer 1 week ago who had a planning for a new building, which was initially an office building. And they made the foundation on that basis, and in the middle of the project, they wanted to put some studios. No way. The weight cannot be carried by the foundations. Same with your network. If you don't have the right specification and vision of what you want to do with your system, and then you mess up with your network design, you're done. So the design of your system to also provide the right benefits in terms of the business return on investment is very important. The delivery of the competencies of the right system integrators. We're working very, very closely at Sony with our system integrator partners across Europe to train them, to enable them as well to deliver the different projects, and also to troubleshoot. And that's why we also help with the support on this project and when it's on air as well, not only with the tools, but with the resource and the knowledge, because that's also important that when you're on the fire of a live production and you have a director losing a picture and shouting at you, I can tell you that you have to fix it very, very quickly. So that's how I try to articulate for the last session of the day. Thank you very much.